We are blocked and we have good to send that command. We have 31 minutes and 32 seconds for our support. Go for status buffer dump.
Because the Hubble Space Telescope is so scientifically effective right now, scientists are using Hubble to investigate some of the deepest mysteries of the universe.
One of the primary things Hubble has been doing is looking at the atmospheres around exoplanets.
If you had asked the guys who built Hubble and designed Hubble, they would have sworn Hubble could never, ever do this.
That's one of the things I love about Hubble, is that it ends up giving us new questions, new mysteries to explore.
My name is Larry Dunham. I'm the Chief Systems Engineer for Flight Systems here on the Hubble Space Telescope. I started on the Hubble program back in the summer of 1982 when Hubble was being built out in California. First telescope in space to be designed so that we've got what we call orbital replacement units. They're modular boxes with handrails on them so the astronauts can go up and just pick and play. They've got nice connectors on them that make it easy for the astronauts with their big gloves to be able to put them in and out.
We've had 5 servicing missions. We have replaced some equipment multiple times, especially the instruments. We're always going with the advanced technology.
The telescope we have today on orbit is not the telescope that we launched originally. We've been able to replace all 5 of our science instruments with instruments that have the technology that didn't even exist when Hubble was being built originally.
The Hubble Space Telescope is really an observatory because it has several science instruments, several modes of operation. We have multiple cameras, multiple spectrographs. They each have different capabilities in terms of their sensitivities or the kinds of frequencies they can receive the electromagnetic spectrum. We can also use Hubble in different kinds of intriguing modes depending on what we're trying to observe.
There are different types of observing scenarios, and one of the things the scientists have been able to do is they've been able to come up with very interesting and unique observing scenarios that allowed them to do science that they never thought they could do before.
Because the Hubble Space Telescope has been operating for a long time, it's giving us what we need to explore the universe in deep ways that would never have been possible when Hubble was first launched. For example, scientists wondered whether we could use Hubble in an innovative mode in recent years, basically scanning objects slowly instead of just staring at them. In some cases, that gives us a higher sensitivity to what we're trying to observe. And we're using that special mode on Hubble now to get better information about many types of things in space, including to be able to study planets around other stars, what we call exoplanets, planets outside of our own solar system.
What Hubble's been able to do is as the planets go in front of the stars that they're going around, the spectrographs can detect changes, very small changes in the spectrum. This has allowed them to do exoplanet atmospheric studies. This is something that Hubble has sort of really stepped up to the plate and has been just phenomenally good at. Spectrographs have really sort of been leading that. If you ever see things about, oh, a new exoplanet was discovered that has this in the atmosphere or that in the atmosphere, or we think it's made of this, it's the spectrographs which have shown you that kind of information. For doing a lot of the exoplanet observations, you have to catch what's known as a transit. One, the orbit of the exoplanet has to be such that it's going to go between you and the star it's going around. We can't just do an exoplanet observation whenever we want or whenever it's convenient. We have to do an exoplanet observation when it's first starting to go into the star. And so they have to know very accurately the timing of that. We have to schedule it ahead of time. This is not something that Hubble can get around to when it wants to. We have to say, no, at this point in time, on this date, you have to be pointed here and you have to be looking here. We had to really think about how to schedule this. A lot of thought goes into it. A lot of thought goes into the planning and of the execution.
The Hubble operations team are quite willing and capable of using the telescope in new modes and new innovative ways that enable us to accomplish science that we wouldn't otherwise be able to accomplish. We asked them, would it be possible to use Hubble to track something moving quickly across the sky. And they figured out a way to use Hubble in a vast tracking mode that enabled us to do explorations and discoveries that astronomers didn't envision using Hubble for when it was first designed.
Now, when we're observing our planets, when we're observing Jupiter or Saturn or Uranus or Neptune, they move also. We have to move the telescope because they're just going around the sun. They're actually moving because they're really moving. And so we have to move with them. We're observing asteroids or comets. We have to chase after them.
Oumuamua, we know came from outside of our solar system, is like a big asteroid that was detected whizzing through our solar system. We wanted to use Hubble to observe this as well, and we were able to track it. This is not a simple operation. It's moving at more than 100,000 miles an hour, so being able to observe this and track it is a wonderful capability that the operations team has enabled Hubble to have.
The telescope is big, it's massive, it moves about the same speed as the minute hand on a clock. So to move from pointing one thing to go completely around the other one takes us a half an hour. It is not a very fast motion. We actually use a very interesting technique. It's using Newton's third law. We have these very large reaction wheels on it. They're about 2 feet across, very, very heavy, very, very massive wheels. You start spinning those wheels one way, the telescope will spin a little bit in the opposite direction. This is how we can move the telescope from one part of the sky to another part of the sky.
Once we've moved the reaction wheels and we've moved the telescope so we're in the right spot, now we have to get in the exact location to put the target in the science instrument aperture.
What's going to happen now is the FGSs are going to start talking to the telescope, talking to the flight software computer and saying, I want you to move the telescope over here a little bit to be able to position the science for the science aperture.
Most of the time we use the Hubble Space Telescope to do observations that have been planned quite a bit in advance. Observers around the world, astronomers will write proposals. We will then take those accepted proposals and observe whatever it is that the astronomer has proposed. But sometimes there are things that happen that are unexpected or rapid events that we need a more rapid response.
We have a capability of what we call a target of opportunity. And that's when something unexpected happens in the universe that astronomers, they want to immediately jump on that as fast as possible with Hubble. Case in point was the gravitational wave detection to neutron stars colliding. A target of opportunity was submitted for Hubble to actually go look at the remnant and see if we could find it.
We had the engineers run through it. We got new commanding sequences from the Space Telescope Science Institute. We were able to run all that through, and then we executed on orbit.
We have to respond very fast. We produce a new schedule and set of command loads.
We can modify a lot of the flight software, modify how the instruments are commanded. It allows us to change. We can react very quickly. What Hubble has done compared to what we were thinking Hubble could do is just amazing. Hubble's had its fingers in almost everything, a neutron star collision, looking for all the supernova, all this stuff going on with dark matter, dark energy, exoplanets. Hubble has just been constantly finding new things. Now we're looking at these interstellar comets and these interstellar asteroids visiting us. It's really been spectacular to watch.
There really are two key aspects to Hubble's design that have enabled us to last the 30 years that we have, and that is really the redundancy that we have on board, and then it's the servicing, putting in new and improved instruments, and being able to improve the hardware with lessons learned over the 30 years of Hubble operations. We are now at our peak performance.
The Hubble Space Telescope has had a profound impact, not only on astronomy. It showed that humans in space and science can go hand in hand to enable us to explore space in richer ways than we could ever do with either just astronauts alone or just with instrumentation alone. By using these skills together, new vistas of exploration are open to us, and that lesson is something we're still benefiting from as we envision future space exploration.
Go ahead. Okay, we have a go for release. Okay, Charlie.
It's
It's amazing with a program that's lasted the duration that Hubble has lasted, that the astronomers up at the Space Telescope Science Institute continue to come up with new things that they want to try to do with Hubble, and we certainly hope that we'll be able to continue to provide that kind of capability to them into the late 2020s and beyond.